Okay, Kashif, I did see your question. We will talk about VPN and other stuff later part of the course, but you can do that, okay?
Okay, thank you.
So we'll start with continuing from where we stopped last class. So we were designing an AWS VPC, and we have made a picture, right? Where is that? So this is what we made, and we deployed all these servers to external facing web servers, one Bastion host. We deployed one application server, we deployed one SQL server, and then these are infrastructure servers. I just put it. So this, any questions on so far what we have done on the VPC? Were you guys able to make a VPC something similar to this? Did
Yes,
anybody
I
try
was.
it? What about others? Did you guys give it a try?
Um,
No, not
Most
yet.
of it
Yeah,
didn't work.
I think we have. I could do.
Okay. I mean, you got to try this, okay? When you see when I'm doing it, it might feel very easy, but when you start working on it is when you're going to see the problem. So we will continue from here. So I believe at this point you all know what a VPC is. You know what a routing table is. You know what an internet gateway is. So let's go to the VPC and start looking at all these options here. So we looked at how to create VPC. We talked about subnets. We talked about route tables. We talked about internet gateways. Egress only internet gateway is a new feature. I'm not going to talk about that. I never tried this. This is egress means outgoing traffic. This is something like maybe sometimes you may want to do it wherein nobody can connect from the outside world to your VPC, but servers in your VPC can go to outside world. If you want to do that, you go to do this egress only internet gateway. This is a new feature that came like, I believe, probably like 3 weeks old. I never seen this before, but I was reading through that. If anybody wants to try it, you can try that. But understand, if you do not have a VPN, you will not be able to connect your instances. So if you only have an egress only internet, that means from instances you can go out, but you cannot connect to the instances. DHCP option sets, we talked about DHCP option set. We created a DHCP option set. We attached that DHCP option set to our VPC, wherein it gives all the DNS and NTP servers and other details. We talked about elastic IPs. We created 3 of them. We attached 3 of these elastic IP addresses to our servers, basically our external facing web servers, and the Bastion host. We attach that. We'll talk about endpoints at a later way. Right now what I wanted to talk about, this is called as a Nat Gateways. So Nat Gateway, actually if you look at here in the VPC dashboard, and if you do this wizard, you can see something like this. See this, there is a Nat instance. I used to teach, Nat Gateway is a new feature that Amazon added probably around 7 months back. It was not there before. In the past, we used to build a Linux instance with natting. So what is Nat? Nat means network address translation. That means your internal IP address will not be exposed to the outside world. So natting is done like this. Let me ask, I want some answers back here, okay? If I have an instance in a private subnet, can that instance go to internet?
Yes.
Okay, how, Elton?
Through the NAT?
Okay, we haven't learned that yet, right?
Yes.
Okay, through the NAT they can go out, but if you do not have a NAT, you cannot attach to that instance. And that we tested that actually. What we did is for that, we actually logged into the Bastion host. From the Bastion host, we RDP to this app server, and then we tried to browse internet. We were not able to browse internet using that. So, so that was the test we did, and we're going to try that one more time now. So in order to do that, I just wanted to verify that we are in the correct shape. So what I'm going to do is, I'm going to the instances, I'm going to log into the Bastion host. Okay, Bastion host IP address is this. So it is using what AMI? Where is the AMI details?
Yeah, all there. Class 10.
Okay, so that's a 2016 server. All right, so let's connect to that server. Okay. So this is the Bastion host. I am logging into Bastion host. Bastion host is in a public subnet. So 100% you should be able to browse internet from here because it is in a public subnet. So if you go Google, you will be able to browse Google from here. Okay, we are getting Google. So that means this is in a public host. What we need to do now is from this Bastion host, I wanted to log into app server, which is in our internal app server, which is in the internal private subnet. It does not have a private public IP address. This is the IP address of that server 10.3.112. So what I'm going to do is from this Bastion host, I'm going to do another RDP session. I'm going to do another RDP from here to that box. I don't know what was
Welcome
the
22.
welcome 22.
Welcome 22.
Okay. No.
I think it was we have created as admin, not administrator.
This is
More choices.
More choices and change the username as admin.
no. Okay, hold on one second. I think that's not the password. We have to get the password. So this is actually Windows Server RTM. So we need to get the password for that. So this is the password for it.
It cannot copy it.
Okay, so that's the password. So we are connecting to the application server in a private subnet, and now we go into it does not have a public IP address. Everybody agree on that? It does not have a public IP address, correct?
Correct.
Yeah.
And now we go and browse google.com. You will not be able to browse google.com. It is going to time out. Oh, okay, I'm recording. Okay, so see that it's not working. So what I'm doing is I'm going to minimize this whole thing. And you can see that it has a private IP address, everything is there. So what we need to do is we're going to go to VPC and we're going to install something called as a Nat Interface. So this is what it is. A NAT will be acting as a computer that will allow the traffic. So this is where our private subnet, that is where our app server is. So we're going to allow this app server to communicate through the NAT to go to the internet. Nobody can connect to that instance, but still that instance can go to internet using that NAT instance. So in the past, what we normally do is we have a public subnet, then we have a private subnet. Okay, no, this is let's say this is a public subnet, this is a private subnet. So here we have a instance. That instance need to go to internet through the IGW. So what we do is we normally, if you have an instance here, can that instance go to internet? It can, correct? Because it's in the public subnet. But this instance cannot go to internet because it is not in the public subnet. So what we do is we build a NAT instance. It is normally a Linux instance in the public subnet. The Linux instance can go to internet. But here you will specify in this subnet's routing table, you will specify 0.0.0.0 can go to where? Can anybody tell me? What will be the
Internet.
value? No,
That
it
computer,
will be
right?
the IP address of
This computer, yeah.
the NAT. So you will specify the IP address of the NAT. So when this computer wants to go to internet, it will go straight to here. And then the NAT will say, okay, I am a NAT server, I know what to do. So he will allow the traffic to go inside. So if anybody wants to try that, I would recommend to try that option. There is actually some awesome videos are there. I'll show you that. I'm not going to get into that. But you can actually Google it. Deploy a NAT instance in AWS. So there will be a lot of documentations here. NAT instance AWS, you know, how you can deploy NAT instances in here. They have clear documentations on, see here, this is the NAT instance. The NAT instance IP address is 10.0.0.8. This is a private subnet. See, look at the route table here attached to that private subnet. 0.0.0 is pointing to the NAT instance ID. You see that? So all these servers can go through the NAT instance to go to outside. The NAT instance will always be in a public subnet where 0.0.0/0 will be IGW. So you can deploy a NAT instance. NAT instance, you don't need to install any software and all. Amazon has pre-configured NAT instances. All you need to do is just deploy that instance and it will work. Okay. I'm not going to do that. I used to do this in the classes, but that is when Amazon came up with this new capability called as Nat Gateways. So they came up with this new feature now called Nat Gateways. So what we are going to do is we are going to deploy a Nat Gateway so that our app server can go to internet. Before doing that, I just want to show you how, if you want to install your own NAT instance, you don't want to use Nat Gateways. Nat Gateways, there is a fee for it, a small fee, you know, like a $2 or something they charge for the Nat Gateways, as well as the traffic that is going through that NAT instance, they will charge some fee for it. But if you do not want to use Nat Gateways, you can deploy a NAT instance inside the public subnet, and then you can route your traffic through the NAT instance to gain access to internet. If you want to do that, you go to EC2 instance, you go and launch instance, and you go to AWS, you can go to community thing and then just type Nat. You just do that, you will see a lot of Nat instances, AMIs you can get it. These are all Nats. So you can pick the Amazon Nat itself. So you can see that this is the Nat instance. All you need to do is you deploy this instance. Make a note of these things. These are very important. Okay, you deploy this instance in the public subnet, and then you configure the route table of the private subnet to point it to this instance. One thing you have to do for the NAT to work is very important. When you deploy the NAT instance, after you deploy the NAT instance, you go to the NAT instance properties, go to the internet networking setting. There is a thing called change source destination check. You need to disable this feature on that particular instance in order for the NAT to work. Disable source destination check. If you normally source destination check will be checked, the computers will check, okay, who is the source, who is the destination. I want to know from where it is coming and to where it is going. If that does not know, the computer won't allow traffic. But when you are doing a NAT, the NAT acts as a proxy, so you cannot have the source destination check enabled. So if you want your NAT instance to work, you have to make this disabled. So I would encourage you guys to try that. I'm sure it works. It is interesting topic. So you don't have to pay for Amazon's provided NAT gateway. But anyway, I don't think you need to do that. This is more stable, because if you have a NAT instance and if that NAT instance gets down or if it gets rebooted or something goes wrong, your internal servers cannot communicate to outside world. So in a real world production environment, I would probably recommend using NAT gateways rather than NAT instances. So we're going to deploy this NAT gateway, very simple. So everybody understand what is the purpose of NAT, right? It will allow your internal private subnet instances to go to internet through the NAT gateway, so that their IP address will not be exposed to the outside world. They do not need a public IP address, nothing. All the traffic will go through the NAT gateways.
So the same can be achieved through a Bastion server?
Same can be achieved through a Bastion server. You have to configure that Bastion server as a NAT instance. I don't know how to do that on a Windows server. In Windows, I don't know how you can configure a NAT. If you can find out a way, then you can do that. Absolutely.
No, I mean, what I'm trying to understand here is like if you're trying to connect to the internet for an instance which is in the private subnet, can you also go through the Bastion server? I mean, I'm not worried about
unless otherwise it is not a NAT. If it cannot route the traffic, then it is not going to allow the traffic.
Okay, like if I specify in the route table that particular instant IP address.
No, it won't do it. That is the thing. The NAT software do the network address translation. You need to have that software to do that translation. Simply pointing it to that server doesn't do that. I understand your question. You're saying, okay, in the route table, let me point to the IP address of the Bastion host. Will it route the traffic? That is your question, correct?
Right.
No, it won't do that.
So I can still not be able to connect to the internet with Bastion server?
No.
Oh, only through NAT. Okay. Thanks.
Only through a NAT. Yeah. So here is the thing, NAT gateway. So let's go and take a quick look at what is NAT gateway. You can use a NAT address resolution or network address translation gateway to enable instances in a private subnet to connect to the internet or other AWS services, but prevent internet from initiating a connection with those instances. Are you clear on this complete this up to here?
Yes.
Everybody clear on that? This allows your internal servers to go out And there are certain situations you need that to happen. For example, if you have a WSS server for patching, if you have an antivirus server, it needs to go to internet. You have a SCOM server, or if you have certain FTP server, these are only particular servers in your company that needs internet access. Other servers actually don't need internet access. But if you have certain servers that need internet access, and you don't want to put them in a DMZ, or you don't want to put them in a public network, you want to still keep them internally, but at the same time you want to allow them to access internet, you have to have a NAT. So you are charged for creating using Nat Gateway in your account. So there is a fee for NAT. There is a pricing. I don't think it is too much costly, but there is a fee for that. Amazon is providing Nat Gateway. So read this definitely. So this is what it is. When you say Nat Instance, actually Amazon is creating a server or an instance in the backend, highly available. That is the beauty of it. Amazon takes care of that. There is no question about a Nat Gateway going down, because in the backend they are providing multiple servers and all. So the Nat Gateway will have a public IP, and then using that public IP, you can specify, see here 0.0.0 will be your Nat Gateway ID and your traffic will go. Okay, so that is the purpose of this thing. Is this picture clear for everybody? So you have your private subnet. We want these private servers to, all these servers can now go to internet using the Nat Gateway. So what it does is, in real world, these servers want to go to internet. They ask the route table. Route table say, okay, 0.0.0 is Nat Gateway. So it will use this router to go to here, and then from here they will go to internet. I mean, it will go through the internet gateway to go out. Okay. So that is what we are going to do. That is what Is Nat Gateway means. It's a new feature. They just recently added this feature, this thing here. It is pretty straightforward. How to create everything is clearly mentioned here. So we're going to do that. Okay. So create a Nat Gateway. Now you specify which subnet you want the Nat Gateway to be. Create a Nat Gateway and assign an elastic IP address. So we need to create that in the public subnet, correct?
Yes.
So it has to be in one of the public subnet. So I'm putting it in the public subnet 1. We need a elastic IP address. We do not have any more elastic IP addresses available. So I'm going to create one more elastic IP address. So I already got an elastic IP address. This is the new IP address, and you create a Nat Gateway. So now a Nat Gateway is created. So you can see you can edit the route tables and things like that. You don't need to do that now. So I'm going to the view Nat Gateway. So you will see that it will come up now in a minute. So here it is. It is spinning up there. I told you, right? Amazon has to create that instance in the backend, and it is doing so. This is the private IP address of the NAT. We don't need that. The NAT has a ID. This is the NAT ID. And then the subnet it is, everything is clearly mentioned here. So now if I want to, so let this come up, but if I want my app server to go to internet, what should I do next? Anybody? I want my app server to go to internet.
Add 0.0 in private subnet.
In the route table, actually.
In the route
So
table.
we have to find out the private subnet where our app server is, correct? So what I do is I will go to the app server itself, and then from there I will drill back. So I go to the app server. I will find out which is the subnet attached to that. So from here I get the subnet details, correct? So this is the subnet, and then I will go to the subnet. I pick that subnet. I will just search that. Okay, that is a private subnet 3, and this subnet will have a route table, correct? This is the route table, class 10 private route table. So we need to go to the route table here, and then we need to edit that route table, correct? In that attached here, I'm going to add a route called 0.0.0.0/0 should be the Nat instance. See here, it will automatically come up. You specify that and you save it. And now this route table, are you guys following what I'm saying? This route
Yes.
table now has the path to go to the NAT, so that the instances that belongs to the subnets that belongs to this route table, they can all go. All of them can go. So this is another question, and that I will explain in the design how you want to really do it. Right now, the class 10 private route table has that route. So all these subnets, both these subnets, all the instances in both these private subnets can now go to internet. Do you really want that?
No.
I don't recommend that, but right now we're going to keep it like that. But if you want that, you create a separate subnet, create a separate route table for it, and put only the servers that needs to go to internet, put it there, and keep them in a separate bucket. You don't want to mix them with your other servers, because now every server can go. Okay? So our internet gateway is getting ready. Sorry, not Nat Gateway is getting ready. It is available now. Now let us take a look and see whether our server. So we are on that server, right, on the app server now. Okay. So we are on the app server now. So hopefully now we'll be able to browse internet. See here, I can now browse internet. Earlier we were not able to browse internet. Are you sure this is the server? We are on the 10.3.112 server. This is our internal app server, correct? From the Bastion host. The outside is the Bastion host. This is the internal app server, and I'm able to get internet now. Is that clear for everybody? So this is how we need to do it. But now the problem is, if you look at this picture, if you look at our design picture, let me ask you one question here. Can this server go to internet now?
Yeah.
Can this server go to internet?
Yes.
If you put
Yes.
another 10 more servers here, they can all go to internet, correct? Because they are all attached to the same route table, and that route table is having a path to the Nat Gateway, so they can all go, right? So this is not the right way you should design it. If you are designing it, I would say you create a new subnet here and attach a separate route table. You can call it as, Nat route table or something like that. You getting what you can call it as Nat route table. In this route table, you will have the route called 0.0.0.0/0, which is the Nat instance. And you put only your antivirus server, only your patching server, only your vSender here. All other application servers and other domain controllers and all will be in these subnets. Now, any servers in these subnets, can they go to internet?
No.
They cannot. Only the servers that belongs to that. So you can create a separate subnet and isolate them. Okay. Now the beauty of using a Nat instance itself, the Linux based Nat instance means you don't have to do this. In that case, you can exclusively specify who can talk to that thing. In the route table, in the security group of this server, you can specify who can talk to through that instance. So there you don't need to do that. That is little different from the Nat Gateway. So Nat, if you are using Nat Gateway, this is the only solution for you to isolate the external traffic. Okay?
Deep, I have a question. So when you create a route table, right, the main route table, the local would come in as default, right? How would you remove that?
No, it won't. You can remove that. We actually removed it. That is how we created our own custom route tables, right? So this is the route table attached to this subnet, correct?
Yeah.
This is the route table attached to this subnet. If you click on that go back one step. So you click on the edit tab. Here you can see all the route tables. So you can switch them. You can have only one route table attached to a subnet, only one. So the main route table is here. When we created our own custom route tables, we actually pointed them to the correct one.
Yeah, but that 10.0.0.0/16, that always exists there, right? If it exists, it can always go out, right?
No, I didn't get you. What is that?
No, if the destination 10.0.0.0/16 is part of the any route table, right?
Correct. That is the local route. That is a local route. That is not external. 0.0.0 is the outside traffic. 10.0 is your CIDR block. That is your VPC network.
Okay. Okay, got it.
Correct?
Okay, yeah.
This is your local network. That is our CIDR block of our VPC. If you look at your VPC, class 10 VPC, you can see your CIDR block is that.
Okay.
That is local. So any traffic local can go through that. Every route table will have that. You cannot take that out.
Okay. Okay.
Yeah, you need to talk to the computer within the same, VPC, right? That's why.
Correct.
Thank you.
Yeah. Devinder, you have a question?
Yeah, the question is this app server we're discussing. What if the app server is an Exchange server? Now, Exchange server needs to go out and it needs to have inbound and outbound both. People need to
If you want inbound and outbound both, then you have to put it in the public subnet.
Yeah, but in the real world, I mean, without using Amazon, right? We don't put Exchange server or MySQL server in a public subnetwork. We put in a private, and you have a Cisco firewall.
Yeah.
Or checkpoint firewall, and firewall does the netting.
If you have a checkpoint firewall, then you can do an exclusive rule on the checkpoint firewall to forward the traffic to your Exchange server. Then you can do that.
Correct, but the point here is we're assuming that I'm going to move my Exchange server to Amazon, my SQL server to Amazon Web Services. Now I can't use my physical Cisco firewall in my location. I have to use everything from Amazon Web Services.
No. No. So I'll come back there. If you have checkpoint licenses, your company is already having checkpoint licenses, you can go to Amazon EC2 and you want to launch an instance. You click on AWS Marketplace and you just go here and type checkpoint. You will get all the checkpoint appliances here. You can get not only this actually. They have quite some checkpoints. So here is the thing, BYOL, bring your own license. So you can put the checkpoint. This is exactly the same checkpoint firewall, different combination, different settings, different features. It depends on what blade you want to put it on your checkpoint. In our office, we have a main checkpoint management server in our own data center, but we do have checkpoint appliances used in Amazon for higher security. But that checkpoints are also managed by our main management server. So here is the thing. So this checkpoint appliance is around, if you deploy this one, it will cost you around $5,000 a year. So there are different models are there. You can do that. Not only checkpoint, there are many different types of firewalls are available. Now,
what about Cisco? Do they have Cisco too? Cisco ASA?
I'm sure it should be there. So here it is. Cisco ASA is also available. Everything is available. If you want to use, we are actually engineering right now to put F5 load balancers. F5 load balancers, GTM and LTMs are also available. Local traffic manager and global traffic managers, they are also available. So pretty much every company has to do this because they are going out of market. Now, believe me, guys, I was talking to my big boss when I was in Merrill Lynch in 2002 to 2006. I was in Merrill Lynch, and my big boss at that time, the person I was reporting, his manager, he was the infrastructure head for Merrill Lynch. Now he is heading the entire Chase Bank. So last week I met him. Last week means actually 3 days back. I met him for a party. And I was talking to him and he said, 2 years back when I talked to him, he said they are completely deploying a private cloud. No, we are not going to Amazon. We're not going to Azure. We have our own cloud. So they have complete VMware platform. they have a VMware vCloud director on top of it. So they had their own VMware cloud, and then they did a lot of automation with VCAC and vRealize and a lot of things. And now they have more complexities and more money. But when I met him last week, he said that they are already started looking into Amazon. They are making a hybrid network. That means they're extending their private cloud to public cloud, in fact, to Amazon itself. And I asked them why. And he said, that is the trend is, the cost-wise, the features-wise, they kind of thinking that Amazon is the final destination for all these companies. And more, the CEOs and CTOs are all getting more comfortable with the security features and the performance aspects of Amazon. So everybody started looking into it. So when we were talking, he was saying very confidently that, the purchase of new hardware into their environments are drastically come down. They are no more purchasing. Most of their purchases are on hold right now. They are not purchasing any more new SAN arrays. They are not purchasing new servers. They are not purchasing new network routers and switches and all, because any new applications or something, dev, test, QA, UAT, all that is going to cloud now, and they're only keeping production servers internally. So you know that a company like Chase or Goldman Sachs and all, if they have 100,000 servers, you're talking about probably a good 80,000 servers are their dev, test, UAT, QA servers. They will only have 20,000 production servers. 80,000 servers belongs to developers and QA and testing and integration servers. Now they are looking to put them in Amazon. So believe me, this is going to be going to happen very fast, and things are moving very, very fast. In the next 5 years, if I'm not mistaken, next 5 years, you can see that 50% of the companies will be in cloud, completely in cloud, and the remaining 50% will be these kind of huge enterprise companies. Probably they will end up with their production environment in their own data centers, and their entire test, dev, UAT environments will be in cloud, and by 10 years, they will be entirely into cloud. So database administrators are scared now. They are losing jobs because there is a lot of database service. Storage administrators, network administrators, they're all actually kind of little concerned right now because there is no more jobs. Even companies like EMC and HP are also struggling right now because what do they going to do if there is no more companies are buying servers? So everybody is changing, everybody is understanding, and this is the reason why companies like Checkpoint and Cisco and F5 and all, they are coming up with these virtual appliances. Nothing but exact same thing as your physical appliances. You don't need to buy this thing. This is just a VM. If if you go to a real F5 GTM, if you look at it, F5 GTM will look like this. So this is how it looks like, F5 GTM. This is a physical box, which will be like $40, $50, $60,000 product. This is how it is. GTMs and LTMs and all. There are different models, different types are there. There are some of them are even big. Now you don't need this, and this was exactly the question that Devinder is asking me. What will I do if I go to internet, to Amazon? You will do the same thing, but you will be using virtual appliances, but it will cost you a lot of money. See here, this F5 will cost you $13,000 a year. It is around $2.50 per hour to run that. Make sense? So you can buy, see, everything also has the option. So if your company is already having having F5, if your company is already having F5, hold on one second. Hey Sunu, what's going on? I'm in the class. Yes. No, everybody is in the class. Everybody is in the class. Check your email. Okay, bye. Okay. So So this is what it is, Davinder. I hope I answered your question, right?
Yeah, no, you did just small part two. So if I were to use my Cisco ASA in the Amazon cloud, then I will not need this NAT gateway. My ASA will become a gateway, correct?
Your ASA will become the gateway. That's correct. That will act as your NAT. That is exactly correct.
Thank you.
So in my one of my first environment in my workplace, when we started Amazon, this is like 2.5 to 3 years back, we started with the Nat instances. We had quite some servers. I'm talking about around 40 or 50 instances. And the internet traffic for those private instances were through the NAT instances. But later, last year, we replaced those NAT with the checkpoint firewalls, and now the checkpoint is acting as my NAT. So we configure the checkpoint and then we decommission the old NAT instances. So that is exactly your answer. So when you put Cisco ASA or checkpoint, you don't need a NAT gateways, where you will have more control and you have more capabilities. Okay. Any questions, anybody? Is it clear? So you got to try this. So this is all these options. Okay. So that is Nat Gateway. So now I want to talk a little bit about another thing. We talked about, you have an instance. That instance is protected by what? Security group, correct? Inbound and outbound traffic is protected by security group. That instance is inside what? Where? The instance is inside a
Subnet.
subnet. The subnet is inside what? Subnet
VPC.
is inside a VPC.
VPC.
Like that. So anyway, this is the subnet. Sometimes they put a lock there. So there is something called as NACL, Network Address Configuration List, NACL, or Access Control List. So every subnet has a access control list. It will tell you who can come in, who can go out. But typically it is open, but I just want you guys to have an understanding of it, because there may be some questions that can come from here for your exam. So let's go and take a look at the NACLs here. So if you look at network address control list, you can see that, every subnet has a NACL. So let's go and look at the subnet here. So if you look at this subnet, let's take this public subnet 1. Okay, this is the public subnet 1, and you know all these properties of a public subnet. We discussed everything here. We talked about the route table attached to the thing, and here is the network access control list. So this list will allow, you can see here, basically this is rules. So the bigger the number, that get the precedence. So here, so you can see that the network access control list, it actually allowing all traffic, inbound and outbound. You can see that inbound and outbound, it is allowing, actually the bigger the number, the more preferences. So here there is a 100 number and there is a star. That is actually a wildcard. You don't need to, here it is allowing all traffic from every source. It is allowing. For outbound also, it is allowing every traffic. Now if you want to block some traffic, you can actually edit these rules, and you can actually change it and deny it and things like that. You can exclusively deny certain IP addresses and things like that on the thing. So if you really want to make the changes, you have to go to the network access control, because every NACL has a number here. You see here access control list. You go to the NACL or go to the network access control list. This is that particular thing. It says that this particular NACL is associated with 7 subnets. I think we have the same NACL across all the subnets, and you can go here. You can see here the inbound rules and the outbound rules. So here you can come here and you can actually add another rule, and you can say, okay, what traffic from what IP address you can block or deny it. But typically, even in large production environments, I do not see anybody making changes to subnets ACL, because most of the time people actually do the control of traffic through the security gateways. Security gateways are the best place to do it. But if you have a enterprise-wide decision that you wanted every subnet, every computers, you need to have a certain rule, then it makes sense to do that at a subnet level, so that entire subnet will have that particular setting. Okay, so you can see that the route, all these subnets in our subnet, they're all having the one single NACL. But if you want, you can change them. So if you have a particular thing, you can actually create your own network access control list. You can create something like test, and then you can attach that to in which VPC, and then you can create that network access control list, and then you can configure. You have all these subnets there. You can come here and you can remove them. I think you could remove all these things. I think you can change that subnet association. No, go back. So you can change that. It's not allowing me to change it. Now this is the default one, right? We wanted to do the test one. So you can see that subnet associations are not there. If you want to attach a particular subnet, you can attach it to that. So here there is no rules. Right now everything is deny, outbound is deny. So when you create a network access control list for the first time, everything is deny. So if you attach this to your subnets, what happens? If I attach this network access control list to a subnet, nothing is going to go out or in, even though you have a security groups that open everything. So this is how you need to troubleshoot. That is what I'm trying to tell you. Okay, but you can always come here and you can add your own rules. You can give it a value, something like 10. More the value, you get preferences. So you can say, okay, all traffic, or you can say all traffic, destination anywhere. Or you can specify a particular thing, 0.0.0.0/0. You can do that, and you can say allow or deny. Here you can specifically, explicitly specify allow or deny to a particular IP address or to a particular instance. I know somebody asked me that question, hey, can I specify a deny to security group? Is that possible in security groups? In security groups, there is no deny, right? You're allowing who can do that. There is no where you can specify, okay, this machine cannot talk. If you want to do that kind of deny, you have to do it through network access control list. It's not very important. I don't recommend basically to modify this, because if you make it complicated, then it is going to create a hell lot of problems to your environment. So keep using the default network access control list, but control your traffic using security groups. Make sense?
Yeah. Deepu, have a question.
Yep.
Suppose if in case I have a security group which is attached to an instance or VPC, like in that security group, it allows traffic to go out. But if I create a network ACL, in that it doesn't allow to go out. So which one will it consider? Will it consider the rule of network ACL or security group?
Okay, and that is a good question, but we will draw this picture. So this is my instance. This instance has a security group that is allowing 0.0.0.0, okay, /0. Inbound is also 0.0.0.0/0. Okay, everything is possible in and out, correct? Now, this particular instance is unfortunately in a subnet that has a NACL, says all traffic deny, right? Can anybody talk to this instance? Can this talk to outside world? Because if anybody wants to talk to this instance, they have to come through here. When they come here, what happens? All deny. When this instance wants to go outside, when it comes here, what is this NACL says? Deny. It will deny. So which one will take precedence?
NACL.
Subnet will take it, right? So
Yeah.
that's how it is.
So I have the other way question. Suppose if NACL is allowing to go out, in and out, and my security group is not allowing to go out or come in, so even then it doesn't go?
No. In that case, in that case, the scenario is like this. NACL is allowing the traffic to come here, but here you have a security group that says, not allowed. It will block them.
Okay.
So security group, that is why I said security group is the best place to do your control. You can decide who can talk or not at the security group level and leave the NACL thing completely open to outside traffic.
In real world scenario, do people use NACL?
I mean, there are in certain sense, it's all up to you to make the decision. If you are smart enough and you know how to manage it, and you can do that. I'm not saying you should not do that. In my environment, we are not doing it. Our networking guys made the decision that, okay, let us control it through the security groups. So there may be some, companies that may be using NACLs, and that is why the NACLs are there, correct? So there are situations, another good thing is, let's say there is a virus attack, right? I have a subnet. This is a good example. I have a subnet that have 1,000 instances with different subnets, with different security groups. There is a virus attack is coming up or something. We came to know that there is some, Amazon immediately notified us, okay, there is a problem. Do I go to individual subnets and make that disable, or is it better to put a block on the
NACL?
So this is probably easy to pull the plug, correct? Okay. So it's up to you to make that decision.
So each subnet have its own NACL?
It depends on where you want to attach it. Each subnet can have it, or it is up to you how you attach it.
Okay.
Right now, if you look at it, this is the default NACL, and that is attached to all the subnets. But if you want to pick and choose, you can always pick and choose which one you want. Here, you can actually pick and choose. Okay, I want these.
I got it.
You can do that. All right. So that's also clear.
Can a subnet have two NACLs?
No.
Okay. So by default, when we choose a checkbox, will be eliminated if it's already on the other one.
Correct.
Okay.
Okay. So now let's move on. Now I wanted to talk about another thing. This is again. So we will come back and do the VPN little later, because I need to see if I can set up. I had a VPN gateway here. I wanted. If possible, let me see if this weekend I can configure my VPN here so that we can do a real test. Otherwise, I will teach this, but I wanted to hold off on VPN for a couple days. Okay. We will do VPN probably by end of this week or early next week. What I want to talk today is, this is the only thing that is left in VPC, what is called as peering connections. And also there is something called as endpoints. I'll talk about endpoint also. But let me talk about endpoint also. If I want to talk, we need to learn S3 first before we do endpoints. So I'm going to talk about peering connections, VPC peering. So can a VPC span across multiple regions?
No.
No.
Okay. So I have a region here. This is Virginia. And Citibank has a VPC here. Goldman Sachs has a VPC here. Chase has a VPC here. Is this possible? Three companies have three different VPC in one region.
Yes.
Yeah.
Is there a possibility that an instance in this VPC can talk to an instance in this VPC?
No.
What is the purpose of a VPC?
Logically
No other
separated
servers can.
machines.
It's a network.
Correct. Logically separate your instances, your servers from somebody else, right? So that you can put your own rules and settings and all. So
Yes.
VPC peering is a mechanism where you can allow traffic between VPCs within a region. Again, it is not possible across the region, but within the region you can have a VPC peering. Now, I'm not going to do this in the practical here, but I will go through that and explain and show you how to do that VPC peering. So it is an interesting topic. Again, this is also a new capability that Amazon added a year back. A lot of companies were asking for this feature for a long time, but at last now they came up with this VPC peering. So a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using IPv4 addresses. Instances in either VPC can communicate with each other as if they are within the same network. Make sense? So there are certain limitations for doing VPC peering. I'll explain that. So let's go and take a look at some VPC peering pictures. Let me see. I think there may be some sample pictures here. VPC peering pictures. No. Is VPC peering. Yeah, peering scenarios. This is what I wanted to show. So here is the VPC peering scenarios here. So we have a VPC A and VPC B, and you can peer them. When you peer them, you get something called just like our Nat Gateway, or just like your internet gateway, you will get an ID like this. When you have a VPC peering, you get something called PCX, and then you specify that on your route table, and then you can peer it. So you can see that VPC A is VPC B. This happens normally. This happens when two companies merge together. When the acquisitions and mergers happens, how do you integrate your two networks? Sometimes your company itself, initially you started one VPC, two separate VPCs, but later point you realize that no, we want to connect both of them together. So you can do VPC peering. But there is one limitation in VPC peering. Can anybody tell me what it is? You cannot do VPC
Have to
peering.
be same account.
No, it
across
has,
the
no,
region.
it can be across two accounts. I can have my, that is why I said, you can do that is how two companies merge together, right? They have two separate accounts, correct?
Oh,
Case and
this is here which are in the same account, as
yeah,
a two peers.
it is within the same account or between two accounts, doesn't matter. You can do VPC peering.
Okay.
Limitation is within the region.
A VPC can only be within a region. So VPC peering can also be only within a region, which I mentioned also earlier. There is another reason you cannot have VPC peering. Anybody?
If you have a same kind of CIDR block.
Correct. That is the answer. If you have two VPCs with the same CIDR block, you cannot do a VPC peering. So if the company that you are buying accidentally has the same CIDR block, then you never can bridge them together or peer them together. And you know why that is not possible?
Yeah,
Overlap.
Overlap, right.
Then you're going to have IP conflicts and overlapping IP addresses, correct?
Yeah.
Does that make sense? Clear? So this is two VPCs peered together. So VPC peering can be done with IPv6 also. Okay. So here is another VPC example. This is very important also. One VPC peered with two VPCs. So here we have VPC A 172.16, VPC C is 192.168, and VPC B is 10 dot CIDR block, 3 CIDR blocks. Can you do a VPC peering?
Yes.
You can. So here there is one important thing you need to understand is it is not transitive. That means VPC A is peered with VPC B and VPC C is peered with VPC B. That doesn't mean that somebody from VPC B can connect to VPC C like this. It is not possible. Keep that in mind, okay? Even though this is the connection, you think that you can actually access anything in VPC C like this. It is not possible. You may think that, okay, I can come like this and access that, correct? That's not possible. Okay? So here it is. VPC B and VPC C cannot send traffic directly to each other through VPC A. VPC peering does not support transitive peering relationship. So this will be definitely for an exam. It will be a question. I'll bet you. This will be a exam question for your certification if you are going to do it. They will give you scenarios like this and they will ask you, can this be done? Okay, so keep that in mind. Transitive peering is not possible in this VPC peering scenario. So when now you're getting, right, if you know a couple of VPCs, you could do that. So here is VPC peering. Now here is another thing, 3 VPCs peer together. Is this possible? In this case, can VPC A talk to C and B talk to everything? Is it possible?
Yes. Yeah.
So this is possible. That means it's complete. So you need to have exclusive peering between all the VPC A is peer to VPC3 to peering connection. So everything is peering connection. So when VPC A to VPC B is through this connection, this PCX AABB. This one is connecting to that. So you need to specify these things on your route table. So if you want to add that to your route table, this is how it is. VPC A, local route. Everybody know, right? Every route table will have the local route. Then it has VPC A has two connections, two peerings, right? One to C and one to B. Both these connections are specified here. Like that for VPC B, you need to specify the connection for VPC C. So if your 3 VPCs like this, your route table will be like this big. How about this one? Is this possible? This is a very good thing, just like you have a central office, you have a head office, and all the companies, all your satellite offices can connect to that. So something like that, you can have branch VPCs across the same region for certain purposes, and then all that branch offices can be peered to the head office. In this
In
case,
this
can
case,
VPC D talk to E or C? No, nothing. Only
no.
they can all communicate to A. And just imagine in this scenario, how big is your route table? Look at the route table. The route table, you can see that VPC A has peering to all the child ones, but VPC B or VPC C or anything, they only have one peering connection, which is a peering connection to where?
A.
Yeah. So here is another connection. So these are all the things. So here it is another very complicated one. Now, this is all who do like this. I don't know. I'm sure there will be companies, they may get into it, but once you know the concept and once you know what peering is and how it is possible, any possible scenarios are possible. Now look at this, very complicated design, but this is absolutely possible. And look at the route table for that, how it is going to look like. The route table is like 2 pages long, because you need to add peering for every connection. Every VPC has a peering connection to every thing. For look at the VPCG, it has a peering to here, it has a peering to here, it has a peering to here, it has a peering to every possible thing. It is just like a mesh connection. So you can design the way you want, and you can have that. So let us is this clear? So this is all, but please read these things, okay? You may want to read a little bit more about VPC. It's nothing rocket science here, but understand the concept of VPC peering, understand the limitations of VPC peering, things like invalid peering connection configuration. See here, you cannot create VPC. What is the problem here? It is saying no. Why is
Same
it?
side block. Same side block.
Same side block. Here also it is same thing. It is not possible. Same side block. Here it is saying, what is this X mark? Does it make sense?
Yeah.
What is
Because
that
B
thing?
and C. Because B and C are not peered.
Correct. B and C are not peered, so you cannot do that. So these are all different things. Again, so you look at your corporate network. If you have a VPN connection, VPC A is peered to VPC B, but you have a VPN connection from VPC A to your corporate network. Can VPC B talk to your corporate network? It's not possible. Again, the same thing. Transitive peering is not possible. Here is another scenario. You understand this picture?
Yes.
VPC A has an internet gateway. So all the instances in VPC A can possibly talk to internet. VPC B do not have an internet gateway. So can VPC instances in VPC B go to internet? That is the question. Is it possible through here? No, it's not possible. Okay. So that is VPC peering. I hope everybody got an idea on that. Let's get on to our class here. We have 2 VPCs here. I'm going to take our couple of VPCs here. Let's go and look at our VPCs. I'm not going to create one, but let's see if we can create a VPC between class 10 and class 9. Is it possible to create a VPC peering between class 10 and class 9 VPCs?
Yes.
If they are in the same region.
Okay, they are in the same region. And anything.
Yes.
What about the side block?
Different. Yeah.
So we can do that, correct?
Yes.
So let's try how to create it. Now these are things that you guys need to try. So I'm going to class 10 VPC, go to peering connection, create a VPC peering. You need to accept certain things. Somebody cannot forcibly go and connect. It is, and both the administrators need to accept that connection. There will be something like pending. We will see that what happens. So create a VPC peering. Let's call it as, class 10 to class 9 dash VPC peering. I don't know whether we can have that long name. Local VPC to peer. So you need to specify the name of the VPC, local VPC to peer. So I'm doing it from class 10, right? So I wanted to do it to class 9. You getting what I'm saying? I'm doing from class 10 to class 9. So I'm going to say, hey, I want to peer to that. So it is saying associated 20.20. thing. It is okay. Now here is the thing. If your VPC that you are pairing, is it belongs to your account, or is it, if anybody, does anybody has an account here in Virginia? I mean, never mind. You can try that. But if I have somebody's account, you give me your account number and your VPC ID, I can peer it. You getting what I'm saying? So this is how two companies do the peering. The other company that I want to peer, they should give the account number and they should also give the VPC ID number. But if I have my own account, do I need to worry about it?
No. No. No.
Okay, so I'm doing this both VPC. This is the source, and then I'm going to say VPC peering connection. So create VPC peering connection. This has been requested, so it is actually requested. This is my VPC peering connection. That is my VPC peering connection here. Peered account is this one. So you click OK. Now you can see here, since it is both belongs to me, I am on this class 9, class 10 VPC here. So let's go to the class 10 VPC and you go to the peering connection. You can see that the request is pending here. I have to actually take this accept and accept the request to establish that connection. You getting what I'm saying? Is this connection established right now? It is not. It is right now here, and then the route table of the VPC, you need to attach that here. So here you come here and you just say accept request and say accept. The connection is active now. Now same thing, you go to the class 9 VPC and go to the peering connection. Okay, I think it is, since it is my own account, it is activated. Otherwise you have to do it at both ends. So now the VPC peering is done, and this is your peering connection thing. The peered VPC, the local VPC, all that information is right there.
So it will not create the route table automatically. We have to create one.
Yeah, the route table, here, you don't have any route table for this region. So this is actually, I think we removed everything. That is actually from the other thing. I think, you need to attach it to, I think I deleted all that. I think you need to specify it on the subnets. Now that is another thing I need to tell you here. Even though you have a VPC peering, okay. Now this is the point. You don't do that here. I will explain that in a minute. I just remembered that. So here is a VPC, and here is another VPC that we are going to peer. Okay, let's say we did the peering. Okay, PC E XX YY ZZ. This is the peering connection. Now can the computers communicate to each other now?
Yes.
That is what we learned so far. But it is not simply going to allow it. You have a subnet here which has 2 instances. I have a subnet here that has 1 instance, and I have a subnet here that has 3 instances or 4 instances. Here I have a subnet that has 2 instances. Here I have a subnet that have 1 instances. Even though you have a peering connection here, none of the machines can communicate at this point. You have to come to the route table attached to this thing and specify that, the peering connection here, then only this. So this, now if you specify this and you specify this here, okay, route tables, this is the route table, this is the route table. Tell me, can this computer communicate to this computer now? They can. But can this computer communicate to this computer or this computer? They cannot, because their route table do not have that peering connection. I'll show you that now. You understand this, what I'm saying? You have to, even though you create the peering, that doesn't mean that you're going to get exclusive complete access. No. it is again granular. You have to go exclusive to your subnets and specify who can connect to where. Okay, and we're going to do that now.
Is it just subnets or
Subnet.
each instance should
No,
have
no,
the
no. It is subnet based.
Okay.
Because route tables are attached to subnets, right? You cannot do that on an instance basis. So it has to be done at the route table. So you go to the route table. Now I don't want this peering to my public or anything. I just wanted it to my private subnet. That is the only subnet I am allowing this peering connection. I don't want my public subnets to communicate. Okay, you following me? Okay. Srikanth, can you mute? All right. So I'm coming here. I'm going to the routes. I need to pick the route table here. Edit. Is this the route table? Yes, that's the route table, right? Now I'm going to add a route table. I think, how do you put that value? I'm not sure. Where is that route table? Okay. So here is the thing. If you want, okay, this is the point I am correcting. I think I did some mistake here. Not mistake, I just want to tell you. If you want the complete VPC to VPC communication, right? If you want to have the complete VPC to VPC communication, then you can specify the CIDR block, okay? Then it will allow communication across. Or if you want only a particular subnet, then you need to specify that subnet only. Okay, if you specify this, I think it will allow. You need to test it, okay, because we don't use peering in our environment right now. We tested it, but we really in production we are not using VPC peering. But if you specify the CIDR block of your VPC itself, I think it will allow complete communication. But I can, you can limit it to a particular subnet also, and that is what I wanted to show you here. So here, this is class 10. If I want to do 20.0.0.2.0/24, I can specify the peering here. You see that? Now I will see the peering. So when I do this, can anybody tell me what am I doing here? That means any instances in this subnet can talk to this subnet. In this case, it is not exclusive to the entire VPC of class 9, only a particular subnet of class 9. If you want to do the entire thing for that thing, then you can do 20.0.0.0/16, and you can specify the peering connection. Are you guys following me? Is it clear, or did I confuse you?
So what happened to individual F-time? Do we still have to go and make changes to the, to the rules?
What is that? Sorry?
No, like remember you saying before we have to go on each subnet and make changes over there.
Yeah, I think
still have to do that.
Yeah, that is correct. If you in your route table, if you specify the entire CIDR block, then it allows.
Okay.
If you don't specify it, then you can go individually. If you don't want, because when I do a VPC peering, I have two companies, so Kashif has a company, and I have a company, and because of some mutual understanding, we discussed we will have a peering. So we created a peering connection here. Now I have certain servers here. This is my company, and this is Kashif's company. So Kashif and we agreed, and I'm saying, Kashif, you can access these servers, and Kashif is saying, okay, you can access these servers. In this case, on the route table, you should not put the entire CIDR block. If you put the entire CIDR block, then everybody can do complete access. But if you explicitly specify only this subnet's name and this subnet's name, then it will only be allowed between those two subnets. So you can restrict the VPC peering just between certain subnets.
Okay. Now my question is, do we still have to go to each subnet route table and make any changes over there, or no?
You have
know
to,
what I mean?
yes. If your route table do not have the peering detail, then you will not be able to communicate.
Okay.
That's spirit. There is no question about it. Your route table should have that path. Otherwise, how does the subnet know where to send the packet to?
Right, makes sense. Okay.
Okay. So that is VPC peering. Any questions on that? I hope it is clear, right? But that is a very important topic, okay? So I would definitely recommend you guys to take a look at it. So we talked about a couple of interesting topics today. We talked about NAT gateways. We talked about peering connections. These are two important things, and we also talked about NACLs. So the only thing that is left here in this VPC section is, believe me, if you are going for an Amazon certification, if there are 50 questions, believe me, at least 5 to 6 questions will be from VPC, maybe more. VPC is probably the most important thing, and they can ask you questions from anywhere in this. And that is why I was spending some time to make it 100% clear how VPC, and there is no rocket science here. I think it is pretty clear for everybody, but you need to understand what is VPC, subnets, and things like that. So I just want to take you guys to a VPC FAQ. I will send this link in the chat window. Please go through this FAQ. There is a lot of things about FAQs here, billing, how will I be charged? There is no additional charge for creating VPC. So somebody asked me the other day about, is there any cost for VPCs? No, there is no cost for VPCs. Then connectivity, what are the connectivity options for VPC? You can do internet gateway, you can have VPN connections. These are all straightforward questions. Can I connect VPN using software VPN? You can use that software VPN to connect to it. Customer gateway, this is we'll learn when we do the VPN. We will understand what are the different encryption levels that are supported. Is there? Then coming down here, IP addressing, what are the IP address ranges you can use. Pretty much you can use any range, but Amazon is recommending, you follow the RFC 1918 and follow those route designs for your VPC. Simply don't go and put like 30.35. Something like that. No, don't do that. Just follow the things. The default VPC is always going to be 172.31. You can use that, but you can always change that. Can I change the size of a VPC? No, you cannot. Once you create a VPC, that's it. You cannot change the CIDR block or the properties of it. How many subnets I can create in a VPC? I know somebody asked me that. You can create up to 200 subnets per VPC. But if you want more, you can always go and ask for request. So is there a limit on how large or small a subnet can be? The large is actually you can create with a /16, or you can actually create with /28, which is going to be the smallest subnet. Can I use all the IP address that I assigned to a subnet? Yes or no? Can anybody answer this question? Can I use all the IP address that belongs to a subnet?
No.
No, first 4 will not.
Yeah, Amazon reserves the first 4 IP address and the last 1 IP address also. Okay, I forgot to tell that. Actually, it also reserves the 255 one also for every subnet. So first 4, and so total 5 IP addresses are not available. Okay. can I assign multiple IP address to an instance? Yes. So I was reading this the other day and I found something very interesting. Okay, I'll tell you that. Just it was a new. This is, I mean, every class I learned something, and one of the things from this class is, based on the VPC class. I was reading about this last week, and I came across something very interesting. So I have a VPC, and I have an instance here in a subnet. The instance got an IP address called 10.0.1.11. I'm building a new instance. Can I give the same IP address to this instance?
No. You can, but it won't
You
work
cannot.
properly.
Okay. Amazon will not allow you to do that. So what I did is I shut down this instance. Now can I give this instance IP address to here, hardcore? You can hardcore an IP address 10.0.1.11. Can I do that? It is still not possible, because even once you give an IP address, a private IP address, once it is given to an instance, that will be there for the life of that instance. If you want this IP address to be given to another instance, the only option is to terminate that instance. Once you terminate that instance, that IP will be available back to the pool. Otherwise, even if that instance is shut down, you cannot use that IP address on another instance. But in a real world scenario, that's not the case, right? If you have a server and that server is having an IP address and you want to build a new server and give that IP address, as long as this server is down, you can use that IP address. But in Amazon, that is not possible, okay? So just keep that in mind.
So one question, if you want to change the IP address of this server manually, can we do that or no?
Mm-hmm. As long as it is you're assigning an IP address that is available in the in the pool. So you can go here, go to an instance, pick your instance.
Right. No, what I'm saying is, the one we're talking about, we cannot switch anymore once you give the IP address. So I can go to the same server, change it to different. Oh, you cannot do that?
No,
okay.
You cannot change that. So when you create a new network card, if you can come here and add network interface, when you attach a new network interface. Now I'm seeing this error message. Can anybody tell me why am I seeing this error message? I'm trying to attach a new network card and I'm getting this error message. Action, networking, attach network interface. Anybody?
I think one network card per instance.
No.
So there is no network card on that subnet.
No, for the T2 micro, maybe one is available, only one.
No, that's not the issue here actually. Every instance minimum you can have 2 instances. The thing is, there is no network interface available on that subnet. So you have to basically go to the network interface. You have to go to the network interface and create a network interface in that particular subnet. Then you can attach it. That's it. When you go and create, because there has to be a network card to attach to it, right? So you have to create a network card. So if you look at here, right now there is 2 of them available, but they are not in our region or in this VPC. You getting what I'm saying? So if you want to attach a network card, you create a network card here and then you will be able to do that. So if you go here and you click the private subnet 3, okay, this is the subnet. You create a network card, auto assign IP address. If you want, I can attach my own IP address. What is the 10.0.3.88? Okay. I'm giving that IP address and I'm creating, second NIC for app server. Because public subnet, private subnet 3 is where our app server is, correct? I'm attaching a second network card to that thing. I'm giving an IP address in that subnet. I know private subnet, the IP address is 10.0.3.88. Okay, it is also asking for a security group. So internal app server security group. So and I'm doing that. So now I created a NIC card, its IP address is 10.88, and now I can attach that to my instance. So if you go here, you pick that instance and go here, attach a network interface card, and you see that network card which we just attached. So you can attach it to that thing. So now this server will have two IP addresses. You see here, the one that came with the primary NIC card, and this is the second network card.
Does it cost an extra money?
No, these are private IP addresses. There is no additional money for it. Extra money is only for elastic IP addresses.
And network are also free. Network card, we can create
Yes.
as many as we want.
Right.
Okay.
All right. So I think, we will stop here today. I think VPC is kind of over, but I have, as I mentioned, there are two topics that I need to discuss in VPC, which we will learn later. We will come back. And the two topics are, one is endpoint, and another one is VPN. VPN itself is probably a day's topic. I will cover that in detail a little later. Right now, if I talk, it will confuse a lot of things, and also I want to see if I could do that. But let me ask anybody in this class, Davinder, do you have a VPN concentrator where we can test something, man, for the class purpose? It will be a great help if you can do that. I had actually a guy called Shankar was there. He was in California. He actually helped me for my 3 other batches. He had a sonic wall firewall. Does anybody in this class have a firewall at their house which we can use for testing? Nothing happens. Don't worry about it. Davinder, can you give me one? Do you have one VPN router at your home?
At home?
Yeah.
Not at home.
But at work?
At work we have, but that's in production.
No, I don't want to do that.
Um,
Anybody else has a VPN router at your house? I mean, if you don't have VPN router, you cannot even test this, okay? But I think we should do
Yeah,
it.
that's what my question actually. So what are we talking about? Like, what is a VPN router exactly? Like, is it a
I mean, you can
central
put,
device?
there are many ways. You can, actually Sophos, Sonic Wall has, not Sonic Wall, Sophos VPN UTC or UTM or something like that. Yeah, UTM, Secure VPN. This is all software, appliances based thing. I didn't get time to do this. This is actually requires some time, but you can actually, this is free edition, home edition, Secure VPN tunneling protocol. You can actually try that. If anybody wants to try this, you can try that, okay? But I have a Verizon connection. I have a dedicated connection. I have a Verizon router now. I need to really figure out whether I can set up VPN on my Verizon router.
Can you send me the link of this website? Can you send the link?
You can just type Sophos UTM.
Okay.
Sophos UTM. Don't go for this. This is not the right URL. I think you should. So do you have a VMware on your house?
I have a workstation, VMware workstation.
Okay. Maybe that's good enough. You download this Sophos appliance. It is come as an appliance. You can see that, UTM version I had hardware appliance. I think software appliance here. So you can download this appliance and configure it. It will come as, it's an ISO file. So basically you can create it as a VM and then make that as a VPN router. That guy actually told me to do it, but I never got time to try this. Okay, but this is very powerful and very complicated, and not complicated, very powerful with a lot of features. In fact, some companies are using Sophos in their production environment. So they are providing, this is basically for, child, protection and things like that, parent control and things like that. There's a lot of features here. He had that and we were trying to do it. So Let me see if I can make my Verizon router to be configured as a VPN. Then we will be doing a real class. Otherwise, I will explain how VPN, what is customer gateway, what is virtual private gateway, how to establish VPN. It's a very interesting topic. We'll talk about it later.
Yeah.
Okay? Endpoint is another topic. We will talk about the endpoint. If I talk now, you won't understand what is endpoint. Endpoint is kind of a service that Amazon is providing to access certain services. Now, starting next class, you will be kind of understanding that, okay, VPC is not just the Amazon infrastructure. VPC is just a part of the infrastructure. So I just want you guys to start thinking about it. So this is Amazon's Virginia region. In this Virginia region, we have different availability zone. This is availability zone A, B, C, and D. And this is where all our subnets are, private subnets, public subnets, infrastructure subnets, your route tables. All these things are here. So your VPC is pretty much here. But this is all Amazon region. So now we're going to talk about S3. S3 is not inside a VPC, it is in that region. SNS, notification service, that is here. IAM, identity and access management, that is here. So there are many other services, this is S3, there are many other services that are available in Amazon which are not inside your VPC but within that region. So if you have an instance and that instance want to access S3, it has to go through the internet to come back and access it. But with the help of endpoint that we will be learning, you can cut this route and you can actually have a backplane, you can directly access S3. So this is the only endpoint service that Amazon is providing right now, but there are many other endpoints they are planning to do it. For example, there is something called as device farm where you can do, we will be learning device farm here. Device farm is a data center itself with all mobile devices for mobile application testing. If I want to test a mobile application today, I have to go through internet and come and access the mobile phone here. But once they develop an endpoint for a VPC, it is called as VPC endpoint for device farm, then I can actually test it straight using that, using endpoint. So that is basically endpoint. We will see how we can create an endpoint to access S3 in the next class. Okay. So coming back here, so I think I would say we are kind of probably around 35-40% is done. Main two topics are completed. EC2, I think you all know what is EC2, how to create instances, how to create AMIs, IP addresses, all that things are clear. Now you know how to create VPC and configure them. Any questions on so far? Now onwards, now we are going to get on to the next level of class. We still have some topics left in EC2 where we will be talking about load balances. We don't have any load balances. So we will talk about load balances and we'll also talk about auto scaling. These are two things that I want to cover. Okay. So once that is done, then we will be getting on. So next class onwards, we will be talking about S3. We have to talk. There is so many things: CloudWatch, CloudFormation, CloudTrail, Cloud Config, device farm. So there are many things we need to talk about it. And Route 53, relational database services. So these are all things. Every day is probably one day per topic. We will be moving forward with that. Okay. But the main two topics were actually EC2 and then IAM, identity and access management. This is where you create roles and policies and things like that. So we'll be looking into those things starting next class tomorrow. So I think we'll stop here today. At least one day we'll stop before 11 o'clock. Any questions if anybody have? Otherwise I'll stop here.